So what will be the lower quartile value?
84.
Not 54. 84, yeah. Eight
You have to find the middle.
of the lower half.
Okay.
Okay, I'm looking for the middle number, and since there's 1, 2, 3, 4, 5. Ooh, wait a minute. 1, 2, 3, 4, 5. There's 6 of them. If it's even, do I have a legitimate middle? Add them together and divide by 2. Yes, sir. 80.5 is correct. Okay, so what he did was take these two values, add them together, and divide by 2. And you get 80.5. We'll have to probably do that again on the upper quartile as well. So we have the 114 and the 122 added together and divided by 2. 118? Okay, sweet. I now have everything I need to actually build the box and the whisker at this point. So with the upper and lower, 71 and 164. Each of these tick marks is 10, by the way. So let's see. The lower is at 71, so I'm going to put a dot right there, and I'm going to put a 71. The upper is 164. I'm going to put a dot right there and 164. The median. Now remember, what's the median? The middle of everything. It gets a solid straight line because it divides your box. Okay? So I need a 98. So that's very close to 100. So it's going to get the line. Now the point above this and the point below this are going to make my box. Right? So the lower one is at about 80. It was 80.5, and that's going to create the bottom part of my box. Oops, I shouldn't have drawn that line. It went too far. And the upper part of my box is at 118. Oh good, I didn't go too far. And then your whiskers connect the ends to the box. So there's your box and there's your whiskers. What would the range of this interquartile be? Okay, so the range of the interquartile
47.
would be 118 minus the 80.5. And what would it be?
It's 47.
Are you sure?
118 minus 71.
No, no, no.
Wait,
The 80.5 is the edge of the box.
what?
71 is the lowest extreme. 37? 0.5. Okay. All right. So that would be that answer, okay? What can you tell me just from looking at this and how the data is displayed? Is there anything kind of interesting here? Nothing unique or different, you think?
That line's long, that one's short.
Yeah, one side's long and one side's short. What's that mean? It's not even, okay. What's causing it to not be even?
The different sizes of the stains.
Yeah, but the sizes are different for a reason. That 164 is what they call an outlier. When you kind of look at the numbers, doesn't 164 seem a whole lot bigger than a bunch of the others as far as their spacing? All right? And this leads me to my professor that I didn't care for that much, the way he did his grades in college, okay? So let's say, I want to show you because this can happen to you, and I want you to be aware of it, and I want to protect you from making a poor choice like I made. All right? So at school, hang on. Hi, thank you. All right. So when I was in college, my professor kind of clustered our grades to determine what grades you were going to get. All right? So maybe there were 8 people, or probably 5 people in this group, and let's say they had grades anywhere from 100 maybe to an 88. And then there was a space, a gap, and then maybe there were something like this, and maybe those grades were anywhere from an 85 to a 76. And then there were other grades down in here, okay? He would just kind of see where the grades were separated, and wherever there was a nice separation, that would be the cutoff. So everybody here got an A. Everybody here got a B. Everybody here got a C. Okay?
What? It doesn't make sense.
Well, but in college they can do what they want to do. So,
No, I'm confused though.
well, there was a gap here, okay? So maybe all of the grades were relatively close, and this difference of 3 was the biggest gap. Maybe everybody had a 97, 96, 95, 94, 93, 92, 91, 80 something, 90, and then there was like an 88. There was a gap of more than 1 or 2. So that would be his cutoff. So at the time of the final, I had an A. I was happy. He says, if you're happy with your grade, you don't have to come take the final. You're cool. I'm like, sweet. So I didn't go take the final. I was pretty sure I was sitting right here. I'm just figuring that was me. I was not in the upper A's for any means, but I was probably the person who had the 88. But if he was going to put me in with the A's, I was okay with that. Then other people went to go take the final. And guess what? The gap changed. The gap changed. And so I was still sitting probably at my 88, but some of these people moved up. And my 88 had a bigger gap, and I got dropped down. I got a B. I was really mad. Really mad. Because had I thought I needed to go back in, I would have, But anyway, so don't let that happen to you. If your professor in college tells you that if you're happy with your grade, you don't have to come take the final, make sure what grading method they're going to use. If they're going to be clustering your grades like that, you might want to go in and take that, or even just show up. I often wonder if I had just showed up, if I would have gotten the A and not even had to take it. Sometimes they'll do stuff like that. So, anyway, do you have any questions on the box and whiskers? Okay. Stem and leaf. Is there anybody who's never seen a stem and leaf ever? Really? Okay. I've had 3 to 7 people in every hour, and so that's something that you should be somewhat familiar with. I know I taught it at the 6th grade, but it's not hard to do at all, and it is an amazing. Oh, time out. Back over here. Note to self. Can you find the mode in a box and whisker? The one that happens most often? If all I gave you was the drawing, the sketch, could you tell me what the mode is? Could you tell me what the mean or the average is? Really? You know how many items were there?
Oh, no.
You don't. Okay. Could you tell me how many items are there? No. It's not real user-friendly. And it doesn't give you good information. You'll never be able to find the average. No average. And no mode. Okay, so keep that in mind. All right, just from the picture. Obviously from the data you could, but not from the picture itself. Now let's look at stem and leaf. Here is a table of how fast some land animals can travel. Okay? So I'm going to guess they're running since they're land animals. My favorite is the cheetah. I think it goes 70 miles an hour.
72,
Really, 72?
I think 72.
That one's on steroids then. Yeah. All right. So, yeah, exactly like you. All right. So, what we're looking here at is stem and leaf. For those of you who have no idea what this is, the stem represents the tens value from this table. The leaf represents the ones value. The leaf will always be a ones value. The stem could be more than a 10, and that's one thing you may not have happened to come across yet. if you are familiar with this. So what this is saying is we're going to put the stem in order from least to greatest, and then we're going to put the leaves in order from least to greatest. And how you would read this is, on my chart up here, I would look through and go, okay, I have some animals that ran in their 30s, so here's a 3. I have animals that ran in their 40s. I had animals that ran in the 50s, the 60s, and the 70s. So the first digit is in the stem. How fast from there is in the leaf, and it's in order. So I have an animal that goes 32, 3 and then a 2. I have another animal that goes 32. I have 3 animals that go 35, because that'd be a 3, 5, 3, 5, 3, 5. I have an animal that goes 36. How many animals will go 40? 4. Okay, so it's easy to count with the stem and leaf diagram. It's real easy to find the mode. What is the mode here? 40. What's the smallest value? The slowest animal? 32. What's the fastest animal? Super user-friendly. Stem and leaf is really a user-friendly data display. Okay, could you find the middle? Yeah, you could just start counting them off, right? Could you find the average? Yeah, add them all up. And here you can count how many there are just from the leaves. So there would be 20 leaves, and you could add it up and divide by 20. So it's a really user-friendly way to organize some data, okay? And it can find just about anything you want. See if you can build a stem and leaf real quick based on the number line that we did over here for these 13 western states. Okay. Oh, right here, because you're going to have numbers that are over 100. Notice here, if the number is over, the first 2 digits are your stem, and the last digit, which is your ones, is still your leaf. So this would represent 117, 119, 211. So that's how you would do the big numbers. See if you can build a stem and leaf real quick.
So you do 10 instead of for the
Correct. For like when you get into the hundreds, yeah, when you got into the hundreds, you'd start with a 10.
And if it goes to like 111, would you do 11?
Uh-huh, I would. So I'm going to look at my table, and I have some 70s, so I know I need a 7. I have some 80s, I need an 8. I have some 90s. I do have a 100, so I would use a 10. I do need an 11. I do need a 12. I don't need a 13, but I do need a 14, and I need a 16.